A charge of 4 microcoulomb is moving with a velocity of 4 into 10 to the power minus along the positive y-axis. So along the positive y-axis, the velocity is 4 into 10 to the power 6 meter per second. Okay, so this is j cap, this is velocity. Okay, under the magnetic field of strength 2k Tesla. So B is 2k cap Tesla. Okay, so B is basically towards the upper side. The force acting on the charge is so simple. So force is going to be Q V cross B. So Q is 4 microcoulomb into V cross B. Okay, in this direction, or we can even see J cross K. So anyway, 4 into 10 to the power 6 meter per second J cap cross 2 Tesla K cap. This is equal to 4 into 10 to the power minus 6 into 4 into 10 to the power 6 into 2. J cross K is I Newton. Now this is given as X. So therefore this gone, X is equal to 32. So X is equal to 32. Okay, because this is X I Newton, so therefore this magnitude of X is actually 32. Thank you. An electron moves through a uniform magnetic field B as this much. At a particular instant of time, the velocity is this much. The magnetic force acting on the electron. So magnetic force is Q V cross B. So what is the magnetic? What is the charge on electron? It's E. Velocity is 3 I cap plus 5 j cap cross B. B naught I cap plus 2 B naught j cap, which is going to be E. I cross I is 0. I cross j is K. So plus 2 B naught into 3 K cap. J cross I is minus K. So therefore this becomes minus 5 B naught into K cap. J cross J is 0. So this is 6 B naught minus 5 B naught. So therefore this is plus B naught into K cap. Okay. So therefore the answer, what is the value of B naught is? Now this is B naught K. So this should B naught K and into E. This is equal to 5E K Newton. So E and E is gone. So B naught becomes 5 Tesla. Thank you. The magnetic field in the center of the wire loop formed by two semicircular wires. So for a circular wire, we have the magnetic field at the center as mu naught I by 2R. Okay. So therefore, for a semicircular, it's going to be mu naught I divided by 4 into R. Okay. So now the magnetic field at the center formed by two of radius R1 and R2. So due to R1, it's going to be, this is for semicircular wire. Now since we can see here that the sense of magnetic field is going to be the same for both for R2 also, for R1 also. So therefore we have to write mu naught I is 4 ampere, so mu naught into 4 ampere divided by 4 into R is 2 pi meter, plus mu naught I, which is again 4 ampere divided by 4 into 4 pi meters. So therefore this becomes, so mu naught is 4 is gone, here also 4 is gone. So 4 pi into 10 to the power minus 7 Tesla meter per ampere into 1 by 2 pi plus 1 by 4 pi, and this is ampere per meter, gone. So this becomes 4 pi into 10 to the power minus 7 Tesla into we have 4 pi 2 plus 1. 4 pi is also gone. So this is 3 into 10 to the power minus 7 Tesla. So therefore the value of alpha becomes 3 because it's alpha into 10, so they're called. Thank you. A coil is placed perpendicular to a magnetic field of 5000 Tesla. Okay, so this is the coil and this is perpendicular to magnetic field. Okay, and the magnetic field is how much? 5000 Tesla. So when the field is changed to 3000 Tesla in 2 seconds, induced EMF. Okay, so phi, which is magnetic flux, is equal to B dot A. Okay, and into N because N turns are there. So the EMF induced is d phi by dt minus, which is equal to E, which is equal to minus of, if you see here, now B dot A, so the angle between them is 0 degree, so therefore cos 0 is equal to 1. So minus dB by dt into A into N. So 22 volts is equal to minus of, now what is dB? dB is the change, so therefore 3000 Tesla minus 5000 Tesla. So this is equal to minus 2000 Tesla divided by dt. What is the t? 2 seconds into area. Area is pi r square by 4. So this is pi into r. So what is r? 0.0 millimeter because the diameter is 0.02. So 0.01 into 0.01 pi r square into n. Okay, so let this pi be now 22 by 7. 22 is gone. This 2 goes with 1000. Okay, so and this is 1 by 10 to the power 4. So this also goes with 10. So n becomes equal to 70 turns. So therefore 70 is going to be the answer. Thank you. A regular polygon of 6 sides is formed by bending a wire of length. Okay, so if you see the magnetic field surrounding a thin straight conductor, this is the formula. Okay, so this alpha and beta are the angles subtended by this conductor on the point P. Okay, so now let us solve this. So we have regular polygon of 6 sides formed by bending wire of length 4 pi meters. Okay, so therefore this becomes a hexagon, something like this, and one side becomes 4 pi divided by 6 meters, which is 2 pi by 3 meters. If an electric current of 4 pi root 3 ampere, so suppose this is the current which is flowing. Sorry. Okay, now what is going to be the magnetic field at the center of the polygon? Okay, so we have this Biot-Savart law, which tells mu naught I dl cross r divided by 4 pi r cube. Okay, so therefore we can see here that it's dl cross r, so dl cross r, okay, in the center. So dl cross r, dl, no, dl, okay, and r is this direction, so dl cross r, like this, up. So therefore the magnetic field produced here is going to be up, and it's going to be like in up direction from all, so therefore it's going to be additive from all the sides. Now let us use this formula. Okay, so it was mu naught I by 4 pi d sine alpha plus sine beta. Okay, so this is let us say this is L, which is already mentioned, 2 by 3 pi, this is L. So okay, now what we are doing is something this. Okay, so we are drawing this here. So if you see, this is, let us say, x, and because it's a regular polygon of 6 sides hexagon, so therefore this is going to be 60 degree. Okay, so this is like 30 degree and this is 30 degree. Okay, and this is 2 pi by 3, this total one. So therefore the half part, this is 2 pi by 6 meters and this is x. So therefore tan 30 degree is equal to 2 pi by 6 into 1 by x. Tan 30 degree is 1 by root 3, so therefore x becomes 2 pi by 6 into root 3 meters. So therefore the magnetic field is going to be mu naught by mu naught I. What is I? I is 4 pi root 3 ampere. 4 pi root 3 mu naught I by 4 pi into d. D is like this distance is d. This x is going to be the d. Okay, as we can see here, this is the d. So d is x is 2 pi into root 3 into 6 into it's sine alpha plus sine beta. So sine 30 degree is 1 by 2, so therefore 1 by 2 plus 1 by 2, and all these 6 sides are going to contribute, so therefore into 6. Okay, now what is mu naught? Mu naught is 4 pi into 10 to the power minus 7. So 4 pi is gone, 2 pi it goes like 2 here, root 3 is gone, and this half and half becomes 1. 6 into 6 is 36, 36 into 2 is 72, 72 into 10 to the power minus 7 Tesla. So therefore the value of x becomes 72. Thank you. A moving coil galvanometer has 100 turns and each turn has an area of 2 centimeter square. Okay, ठीक है, तो ये है moving coil galvanometer का एक diagram, and we can see here that these are the wire loops. Okay, so these wire loops, they are responsible for the magnetic moment of the galvanometer. Okay, and we can see that the magnetic moment is equal to Ni into A. Okay, which is very clearly visible. Now if you see, the magnetic moment is going to be, like if suppose the current is flowing in this direction, okay, like this, so then for the magnetic moment is going to be upwards. Now the magnetic field produced by the magnet is 0.01 Tesla. Which magnet? So these are two magnets, and therefore the magnetic field is in this direction. Okay, and the deflection in the coil is 0.05 radian. Now if you see, then the torque on the magnetic moment is going to be m cross b. Okay, so m cross b, so if you see, m cross, so this is m cross b, so in this direction, so it's going to turn like this. Okay, so if it is going to turn like this, the pointer moves here. Okay, and the pointer will move till here, till which time? Till this torsional spring, there is a theta deflection, and this torsion spring's theta deflection gives it also a torque which is equal to k into theta. Now what is k? K is the torsional constant which is mentioned. The torsional constant of the suspension wire is this much, and theta is the deflection. Okay, so the deflection of the coil, it is theta radians. Okay, so now if we, now let us solve this entire thing. So therefore torque which is equal to m cross b should be equal to k into theta. Now what is m? M is n I a cross b. This should be equal to k times theta. Since we can see both are at 90 degrees, Okay, so therefore both are at 90 degrees. That means M and B both are at 90 degree. So this is B magnetic field and this is M. Just so since both of them are at 90 degrees, so therefore sine 90 is equal to 1. So now we'll just put in the values. N is 100, I is 0, I is, so this is N and this is I, then 10 milliamperes. So therefore 10 into 10 to the power minus 3 amperes into A, the area is 2 centimeters square. So therefore we write 2 into 10 to the power minus 4 meters square into B, which is 0.01 Tesla. 0.01 Tesla should be equal to K. This is K into theta. X into 10 to the power minus 5 Newton meter per radian into theta. What is theta here? The deflection is 0.05 radian. Okay, gone. Now the magnetic field is so basically QVB is equal to F. Okay, so Tesla is force divided by QV. So I'm writing here Newton divided by Q is Coulomb into meter per second. Now if you see Coulomb per second is current, so this is gone, meter is gone, N is gone, M is also gone. So units, they are like completely gone. So because the answer is going to be just a number. So now again coming here, solving this is 10 to the power minus 5 here. Okay, remove this becomes 10 to the power minus 2, this becomes 10 to the power minus 2. Okay, so now 10 to the power minus 2, 10 to the power minus 2 is gone, 10 to the power minus 5 is gone with 10 to the power minus 7, and this is 10 to the power minus 5. So therefore X becomes 10 into 2 divided by 5, which is 4. So the value of X becomes 4. A uniform magnetic field acts along the positive y direction. So this is the direction of magnetic field, which is 2 into 10 to the power minus 3 Tesla. A rectangular loop of sides 20 centimeter and 10 centimeter with current of 5 ampere is in YZ plane. So what is YZ plane? So this is X, this is Y, and this is the Z plane. So therefore the loop is something like this. Okay, so this is the loop, and it is 20 centimeter by 10 centimeter. Okay, the current is in the anti-clockwise sense with reference to negative axis. So that means if we are looking from here, the current is in, if I'm looking like here, so I'll be my image will be inverted, so you have to like look from your side. So I am looking from the negative, no, it's a negative axis, and the current is in which direction? Anti-clockwise sense. Okay, so this is the direction of the current. Okay, so if the current is like this, so therefore anti-clockwise direction negative, so therefore this is going to be the magnetic moment. Now what is this magnetic moment going to be? Ni into A. The magnitude and the direction of the torque is, so therefore it's going to be simple. Torque is going to be equal to M cross B, which is going to be Ni A cross B. Now N is 1, current is 5 ampere, and area is 200 centimeters square. So therefore we are writing 200 into 10 to the power minus 4 meter square. Okay, and it is in minus I direction. Cross B, B is 2 into 10 to the power minus 3 Tesla, and it is in J direction. So therefore minus I cross j is going to be minus k. So therefore it's going to be minus 5 into 200 is 1000, so gone. So this is going to be 2 into 10 to the power minus 4 minus I cross j is actually minus k. So 2 into 10 to the power minus 4 Newton meter along negative z direction. Okay, so therefore B is going to be the answer. Thank you. Two circular coils P and Q of 100 turns each have the same radius as pi centimeter. The currents in the P and R are 1 and 2 ampere respectively. P and Q are placed with the planes mutually perpendicular with the centers coincide. Okay, now P and Q are mutually perpendicular and their centers coincide. So if I write as P like this with this as the center, Q is going to be something like this. Okay, so if you see these are in two mutually perpendicular planes. Their planes are mutually perpendicular, and but their center is going to be the same. The resultant magnetic field induction at the center of the coils is root x. So if you see, like magnetic field due to a circular loop is going to be how much? Mu naught into I divided by 2 into R. Okay, so of course n turns are there, so therefore we will multiply it by n, and both are going to be perpendicular to each other. So if you see let us say the current is like this, so therefore it will be so magnetic field due to Q will be up. So this is magnetic field due to Q, and magnetic field due to P. Okay, if suppose it's in this direction, so in this way, in this direction. Okay, so this is magnetic field due to P. Okay, so it's mu naught I by 2r into d. So let us find out. So magnetic field due to Q becomes mu naught, which is 4 pi into 10 to the power minus 7 Tesla meter per ampere, mu naught into I. For Q it is 2 ampere. Okay, and divided by 2r, 2 into r. What is r? R is pi centimeter. Okay, and this is will be like turns will be n. So this is magnetic field due to Q. So pi and pi is gone, 2 and 2 is gone, ampere and ampere is gone, and it was pi meter. Oh, it's pi centimeter. So here we will write 10 to the power minus 2 also. So meter and meter is gone. So 10 to the power minus 2 and 100. So it's going to be 10 to the power minus 3. So therefore it's 4 into 10 to the power minus 3 Tesla due to Q. Due to P, it's going to be 4 pi into 10 to the power minus 7 Tesla meter per ampere into I. I was 1 ampere. Now, mu naught I by 2 into D. D is again pi centimeter. So pi into 10 to the power minus 2 meter into 100. So this becomes 2 into pi is gone. So this is 2. And this becomes 2 into 10 to the power minus 3 Tesla. So therefore the resultant is going to be, now because both of them are like perpendicular to each other, so like this is BP and this is BP and this is BQ, so therefore it's going to be root over 4 square plus 2 square into 10 to the power minus 3 Tesla, because this is the direction of the magnetic field now. So therefore root 16 plus root 4 is 20. So root 20 milli Tesla. So therefore X will be 20. Thank you.
A horizontal component of the Earth's magnetic field is this much. Very long straight conductor of root 2 ampere in the direction from southeast to northwest is placed. So this is southeast. Let us mark the directions. This is south, east, north and west. So this is how the conductor is placed. Okay, and horizontal component of the Earth's magnetic field. Earth's magnetic field is such that the geographical north is Earth's south pole, magnetic south pole, and this is magnetic north pole. So therefore the magnetic field is in this direction. Okay, so now we have the force per unit length. Okay, so force per unit length, so therefore it's going to be IL cross B. So what is I is root 2 ampere into L, length is 1 meter because it's per unit length. Okay, cross B is 3.5 into 10 to the power minus 5 Tesla, and because it is cross, so therefore it's going to be equal to sine 45 degree, which is actually 1 by root 2. So the root 2 is gone, so therefore this becomes 35 into 10 to the power minus 6 newtons. So per meter it's 3.35 into 10 power minus 6 Newton per meter. So therefore the answer is going to be 35. Thank you. A ceiling fan having 3 blades, okay, so the blades are 3, and length of 80 centimeter, each is rotating with an angular velocity of 1200 rpm. So this is a ceiling, this is the blade of the ceiling fan, and this is the length is 80 centimeter. Okay, and it is rotating, so this is rotating with 1200 rpm. So omega is equal to 1200 rpm, which is 1200 into 2 pi radian divided by 60 seconds. So this becomes 20. So this is 40 pi radians per second. Now the magnetic field of Earth in that region is 0.5 G. Now what is this G? G is Gauss, and 1 Gauss is equal to 10 to the power minus 4 Tesla. So this has to be remembered since it is asked in JEE in 2024. So therefore they want us to remember this as a standard unit. And the angle of dip is 30 degrees. So basically what they are telling is the magnetic field is something like this in that region, in this direction, which is 0.5 Gauss, and this is the dip, which is 30 degree. So this is horizontal magnetic field, and in this direction this is vertical magnetic field. So therefore the vertical magnetic field is 0.5 into sine 30 degree into 10 to the power minus 4 Tesla, which is sine 30 is 1 by 2, so therefore 1 by 4 into 10 to the power minus 4 Tesla. Okay, now see, this is this is a fan, and this is the vertical component of magnetic field. So therefore we can write the magnetic field is, see, if omega is in this direction, you know, like this is how it is moving. So therefore the magnetic field is like in this direction, which is B, V. BH is not going to play any role because it is yes, it is not going to play any role. BH is not going to play any role. Okay, so let us go ahead. The EMF induced in the blades is n pi into 10 to the power minus 5 volt. Now if you see, we have this formula for the EMF. EMF is equal to V cross B dot L. But now since omega is here, so therefore at each point the velocity is going to be something different. So therefore let us take x distance. So here the velocity is going to be omega x, and let us make it as dx. So therefore the field is going to be omega x, not field, the EMF induced here is going to be omega x into b cross b, which is 1 by 4 into 10 to the power minus 4 Tesla. Okay, and v cross b, so this is v cross b, okay, in this direction, so dot l. Okay, so dot l, so l is like dx, so like this we are going to have. So this is the EMF induced, small EMF which is induced due to this small, at this small length. So therefore total EMF induced is going to be integration of this, which is equal to 1 by 4 into 10 to the power minus 4 Tesla into omega x square by 2 from 0 to L, so therefore it's going to be L square by 2. So therefore 1.4 into 10 to the power minus 4 Tesla into omega. Now what is omega? 40 pi radian per second into L square by 2. Now what is L? L is 0.8 meters. So we are writing 8 by 10 meters into 8 by 10 meters into 1 by 2. This is the EMF induced, which is n pi into 10 to the power minus 5. Now yes, so we have to calculate now. So if you see here, 4 into 2 is 8, so 8 it is gone. This and this is also gone. We have okay, this is volt here. Okay, pi and pi is also gone. 10 to the power minus 5, so if this goes here, this becomes into 10. Okay, 10, and again this 10 is also gone. So 4 into 8 is actually 32. So therefore the value of n becomes 32. So therefore the answer is going to be 32. Thank you.
A rigid wire consists of a semicircular portion of radius r. Okay, so this is radius r and two straight sections. So these two are the straight sections. The wire is partially immersed in the perpendicular magnetic field of B naught J cap. So this is B naught J cap, which is pointing outwards. As shown in the figure, the magnetic force on the wire, if it has current I, is, and it is having current I. So now we will understand, simple thing. Like we have a diagram here. So the force on a current carrying wire is given as this. dF is equal to I dl cross B. Okay. Now what is dl? dl is the small length, the elemental length. B is the magnetic field. dF is the force on the wire. Now since it is the dl is not in one direction, so therefore we can what we have to do is we have to sum it up. Okay, so we have to integrate it. Now if we see very clearly, so this entire force is going to be I, okay, dl cross B. Okay, so therefore we have dl1 cross B, okay, plus dl2 cross B, and so on. So what we have done is we have broken this dl in small elemental length. So this is dl1, this is dl2, 3, and so on. Like that we have broken it up in different elemental lengths. Okay, so dl1, dl2, dl3, dl4, dl5, dl6, dl7, dl8, like that we have broken up. So therefore if you see, the force becomes, now if you clearly see, this becomes I into dl1 plus dl2 plus so on cross B vector. Now this entire thing actually becomes displacement. Okay, like displacement in the sense means the vector from a to b, a to d here. Okay, because all these together becomes actually this. Okay, so therefore we can write f is equal to I, okay, l a d cross b. Okay, so this, what is this? This is, vector, length vector from initial to final position of the conductor. Okay, now we approach this question again. So if you see, this is how the current, like the wire starts. So wire starts and it goes till here. So basically, actually the length becomes this is the resultant length, because this is the initial and this is the final point. So therefore the force is going to be I L cross B. Now what is F? Force is I. I is mentioned here is I only. L is 2R I cap, because it's in this direction. Cross B, B is B naught J cap. Okay, so okay, just a minute. No, it is having Z above, no, so it is not B naught J cap, it's B naught K, because it's in upward direction, so it's in K direction. Here also B equals B naught J. No, it should be not B naught J, it should be B naught K, because if you see here, they have mentioned the K value is upwards and B is also pointing in this direction. So therefore the force becomes I cross K. So therefore the force becomes, okay, so I cross K is minus J, so minus 2 I R B naught J cap. This is D. Thank you. The current of 5 ampere flows in a square loop sides of 1 meter placed in air. The magnetic field at the center of the loop is. So you see here, this is a straight wire which is subtending an angle of alpha and beta. Okay, like the positive y part is subtending alpha and the negative y part is subtending beta, and it's carrying current in the upward direction. So therefore the magnetic field produced at P is equal to mu naught I by 4 pi d sine alpha plus sine beta, and this is an entire derivation. We are not going into the derivation, and derivation is actually not that complex, but it is by the application of Biot-Savart law. So now here also we are getting the same thing. Okay, and the direction of the magnetic field at P is also downwards. Okay, because it's going up, so therefore when it's going up and P is located here, for me P is located here, for you it may be like other side. So when it is going up, this is going up, so it's going to have magnetic field like this. So at P it's going to be inside the plane of the paper. So now let us solve this. So we have a current in this direction, current in this direction, and this direction. Okay, and now for all sides, if you see, inside the current is downwards only. Okay, so at P the current is going to the magnetic field is going to be in the downward direction, because see, due to this also it's in downward direction, it's in downward, all due to all it's in downward direction. So let us calculate from 1. Okay, so this is a square loop of 1 meter, so therefore this becomes 0.5 meters, and this is 45 degree, that is pi by 4. So therefore we have magnetic field due to one wire, okay, is mu naught divided by 4 pi into I. What is I? 5 ampere, divided by d, which is 0.5 meter, into sine alpha, that is 45 degree, sine 45 degree, that is 1 by root 2 plus 1 by root 2. And this is due to one wire, okay, through all the four sides it's going to be into 4. And this is said that this is x root 2 into 10 to the power minus 7 Tesla. So now we have to find x. So mu naught is 4 pi into 10 to the power minus 7 Tesla meter per ampere. So this is 4 pi into 5 ampere divided by 5 meters into 10 into its root 2, so it becomes 2 by root 2. So 2 by root 2 is actually 2 on root 2 into 4. Meter is gone, ampere is gone, 5 is gone, 4 pi is gone. Root is equal to x root 2 into 10 to the power minus 7 Tesla. Root 2 and root 2 is also gone, and 10 to the power minus 7 and 10 to the power minus 7 is also gone. So x becomes 40. So the value of x is 40. Thank you. Two particles x and y have equal charges. Okay, so both are having charges q and q, and they are being excited through the same potential difference, that is v. So therefore we can clearly see that the energy possessed by x and y is going to be q into v, which is equal to half mx vx square. This is for x, and for y this is going to be qv is equal to half my vy whole square. So this is first and this is second. Now thereafter they enter in a region of uniform magnetic field and describe circular paths. So now we see here that mv square by r should be equal to qv cross b. So once it enters a magnetic field, so qv in this case, okay, this is electron, so therefore it is like this. So therefore we have radius is equal to mv divided by qb. Okay, now since radius equals to mv by qb, so therefore we can clearly write that r1 is equal to mx vx divided by q into b, and r2 is equal to my vy divided by q into b. This is third and this is fourth. Now since both energy are same, so therefore half mx vx whole square should be equal to half my vy whole square. So therefore vx by vy, okay, should be equal to root over my by mx. Now let us calculate r1 by r2. This is going to be mx vx by my vy, which is equal to mx by my into vx by vy is root over my by mx, which is root over mx by my. So taking square on both the sides, mx by my becomes r1 by r2 whole square. So therefore B is going to be the answer. Thank you. The magnetic potential due to a magnetic dipole at a point on its axis situated at a distance of 20 centimeter is this. Okay. अब देखिए ध्यान से, electric dipole and magnetic dipole, these are the similarity in the formulas. Okay, so dipole moment is q into 2l, magnetic dipole is m into 2l. Then we have field at a far away point on an axis. It is 1 by 4 pi epsilon and 2p by r cube. Here it's mu naught by 4 pi into 2m by r cube. So basically what happens is that at all places the k, which is 1 by 4 pi epsilon naught, gets replaced by mu naught by 4 pi in case of magnetic, and the p gets replaced by m. Okay, so since all of us, we have a very clear, more we have a better idea of electric dipole. So better is if we can compare both of them together, and we can see very clearly here also that this same thing here it's happening. P gets replaced by M. So now we go to the formula of potential due to an electric dipole. It's Kp cos theta by r square. So therefore potential due to magnetic dipole is going to be mu naught by 4 pi into M cos theta divided by r square. Now since here it is being stated that it is on its axis, so therefore at the axis, if you see, the theta is going to be 0 degree. If it is there on the other side, the theta is going to be 180 degree. So basically cos theta will become -1, but the magnitude is not going to change of the potential. So therefore we have mu naught by 4 pi into M divided by r square. Now what is being said here, that the potential is given. Okay, potential is given, we have to find out the magnetic moment. So therefore it's quite simple. Mu naught by 4 pi into M by r square is equal to the potential. Let us write down. So this is 10 to the power minus 7 Tesla meter per ampere into M divided by r square, which is 0.1 meter, because 0.2 meters. Okay, so I am writing here 0.2 meter into 0.2 meter. This should be equal to 1.5 into 10 to the power minus 5 Tesla meter. Tesla is gone, meter is also gone. So therefore the magnetic moment becomes, if you see now, this 10 power minus 5, this goes as 10 to the power minus 2. Okay, now 10 to the power minus 2, it goes down with 100. So this is gone, this is gone. Okay, so therefore magnetic moment becomes 1.5 into 4, which is 6 into ampere meter square. Okay, so therefore the answer is going to be 6. Thank you. Two long straight wires carry equal currents in opposite directions as shown in the figure. The separation between the wires is 5 centimeter. So this difference is 5 centimeter. Okay, the magnitude of the magnetic field at a point P midway between the wires is, so for a infinite long wire, the magnetic field is going to be mu naught I by 2 pi r. Okay, so now if you see, the distance from the wire is 2.5 centimeter. So now for this 10 ampere, it's going to be like this. Okay, so therefore it's going to be like downwards, and for that, this right 10 ampere, it's going to be like this. So therefore again okay, it's going to be down only. Okay, so the magnetic field is downwards due to both the wires. So therefore mu naught I by 2 pi into 2.5 centimeter due to both the wires, this is going to be the magnetic field at P. So therefore we have 4 right here, 4 pi into 10 to the power minus 7 Tesla meter per ampere into I, what is I, 10 ampere divided by 2 pi into 2.5 centimeter. So therefore 2.5 into 10 to the power minus 2 meters. Meter is gone, ampere is gone, 2 pi, so this becomes 2. Okay, this becomes 4, and of course this was multiplied by 2, so therefore into 2 also must be there. So therefore now this 10 to the power minus 2, so this becomes 10 to the power minus 5. Okay, so 2 4s are 8, 8 2s are 16, 16. So 16 into 10 to the power minus 5 Tesla, which is actually 160 into 10 to the power minus 6 Tesla, which is 160 mu Tesla. Proton is moving with a constant velocity, passes through a region of space without any change in its velocity. Okay, that means on the proton, the force due to electric field and force due to magnetic field, if at all present, has to be like the net force has to be 0. Okay, so if E and B, so this is the proton which is having a E plus charge. Okay, so if E and B represent electric and magnetic field respectively, then the region of space may have, okay, so first E is equal to 0 and B is equal to 0. So yes, correct, because now the so force due to electric field is going to be equal to QE, force due to magnetic field is going to be equal to QV cross B. Okay, so now this also becomes 0, so this is also 0, this is also 0, so fine, so this is correct. Second, electric field force due to electric field is 0, okay, but the magnetic field is not 0. Okay, see, magnetic field is not 0, but so we have, we can write now QVB sine theta. So magnetic field is not 0, V is also not 0, but sine theta can be 0 na, if velocity is along the direction of magnetic field. So yes, this also is possible. Okay, now electric field is not 0 and B is equal to 0. Now in this case there is going to be the force QE will not be 0, but so this is also gone, and both E is not equal to 0, B is not equal to 0. Yes, this is also possible, because now QE in this direction, Q into V cross B in this direction, net force is going to be 0. So therefore this also can be there. So just C option will not be there, but A, B and D are possible. So therefore C is the